All right, we did multiplication, right, of polynomials. Let's just review a little bit. So if I had something like this, I squared it. What do we do? Do I just go x squared plus 3 squared? No. All right, that's a big no-no. So what a lot of people do, okay, but that's not correct. So what do you have to do? You're going to multiply it by what? Itself. Okay, so it's x plus 3, and then you just do basically distributive property, don't you? All right, so what would that be? That'd be x squared plus 3x plus 3x, which is 6x plus 9, and you're good to go. Right? What if you had something like this? What would you do there? You write it out 3 times. It's x plus 3 times x plus 3 times x plus 3, all right, and then you do that. So look, we already got 2 of those, don't we? Watch that. I'll tell you what, I'll write it out just to show you. All right, there's 2, and then there's 3. Now look, what you can do, if you want, you don't have to put a bracket there, I'm just doing it just to show you. Like if you were going to multiply, I think we talked about this before, didn't we? If I said 3 times 4 times 5, does it matter what order you multiply these in? It doesn't make any difference. You could go 3 times 4 is 12, times 5 is 60. Or you could go, what? 4 times 5 is 20, then times 3 is 60. Or you could go 3 times 5, which is 15, times 4 is what? 60. Would you agree? It's called the commutative property of, make sure, yeah, it's a commutative property of multiplication. So watch. What I'm going to do here is I'm going to multiply these two together. Now I don't have to do all the work, I just did it a second ago, didn't I? So what's that going to be? It's going to be x squared plus 6x plus 9, right? Now what do we do with that? Multiply it by another x plus 3. Basically it's kind of like taking this, isn't it? It's like multiplying these two together, getting an answer, and then doing what? Multiplying it by that. Would you agree? It's the same process. A little more complicated, obviously, but it's the same process. Now, what do we do with this? Do distributive, right? We learned how to multiply a binomial times a trinomial, so let's do that real quick. What do we get? X cubed plus 6x squared plus 9x. Then we multiply the 3 plus 3x squared plus, what, 18x plus 27. Add like terms. There's no other x cubes, so x cubed. There's a couple x squareds. What's that going to be? Plus 9x squared, right? Bang, bang. What about this? That's going to be 27x, with me? And this is going to be, what? Just 27. There you go. Get the idea? All right, let me ask you this. What if they gave you something like this? That's a little bit of work, isn't it? All right. So really, now look, there's the x cubed and there's the x squared. If you wanted to, you could take this, multiply it by this, but then you're going to get some big old crazy answer, aren't you? All right. Wouldn't you like a better way to multiply that together than have to do all that mess right there? Yeah. So that's what we're going to learn today. All right. You may look at it and say, that really wasn't that much better. I don't know, okay, at the end of this. But we'll try to show you. This is probably something that you have not learned in Algebra 2. I don't think they did this in your Algebra 2 book, okay? So this will be something that's a little new for you that you hadn't seen before, all right? Let's pause this. I'll erase all this, and we'll start from scratch. Okay, what we're gonna learn is this thing is called Pascal's triangle. This is it's just to help us out a little bit. Pascal's triangle. It's actually kind of cool. Watch, what it does is this. It starts off with a 1 on the top, right? And then, watch, this kind of drops down diagonally. That becomes a 1. This drops down, and that becomes a 1. Basically, what you did is you went, there's no number next to it, right? So basically, I went 1 plus 0 is 1, and then this 1 plus 0 is 1. All right? Now, watch what I'm going to do here. You'll see a whole bunch of 1s in this. And I'll talk about in a second. Let's do the triangle first. Establish a pattern, then I'm going to show you how it's useful, okay, and why we're going to use it. It will be very useful. Now watch what I'm going to do. Take this 1 and this 1. I'm going to add those up. Of course, what do you get? 2. Right? And now take this one, stick it on the end. Take this one, stick it on the end. You're going to see this is going to make a nice triangle. All right? And this whole side of this triangle is going to be all 1s. This whole side of this triangle is going to be all 1s. All right? And we're just going to fill in these numbers in the middle. I'll tell you what, let me just kind of scooch that over just a little bit, just so it kind of follows a nice diagonal form here. Okay? Now, look what we did. We took 1 plus 1 and we set it equal to 2. We put it in between those two numbers right there. Do you see that? So let's do the same kind of thing, but now we got a couple things we're going to add up. So what do you think we're going to do here? Well, actually, remember what I said it's going to be on the ends? You're going to have a 1 on the end here and a 1 on the end here. Do you see how it's coming out diagonal like this? Now, we take that 1 plus 2 and we make it into a what? 3. And then this is 2 plus 1. We're going to drop it right here. That becomes 3. Can you do the next line on your own, do you think? Put a 1 right here. Put what? 4. Put 6. Put 4. And then put a 1. Alright, let's do one more. Put a 1 on the outside. What goes here? 5, 10, 10, 5, and 1. You get it? Let's do one more just for fun. Alright, put another 1 out here. What's going to go here? 6, 15, 20, 15, 6, and 1. Good. You get it? Alright, you could keep doing that if you wanted to. Now these numbers represent something. Alright, so be able to do the triangle. Did you do that on your own? Alright, you should be able to. Okay, if you want to go to the next step, you could. We're just going to stop right there. Alright? What this is going to give us is these numbers represent coefficients for what we did a little earlier. Now we had 1x squared plus something x. I should have written those answers down for that. Did you write it down? Aubrey, did you write it down?
For what?
X plus 3 squared. Oops, that's supposed to be it too. So that was what? X squared plus what? 6x plus 9. Actually, let's do it like this. How did we get the... let me think. Yeah, we went 2 times... Nah, I want to write it a certain way. And then we did what? We went plus 3 squared. Would you agree with that? That's what we did there? Would you... And then for the x plus 3 cubed, what did we get? We got x cubed, right? And what was the next... What was the next one? For the x plus 3 cubed. Plus 9x squared. Okay, now watch. It's what? It's... let me make sure I do this right. It's 3 times what? 3, right? And then with an x there, correct? Alright. Oh, this was x squared, though. That's x squared. So what was it? It was 9x squared, right? Okay, what was the next one? Plus 27, so what would that be? That would be... It would be... Yeah, 3 times... hold on, I'm just trying to see how this thing works. Actually, forget that. That's going to confuse you and me. Alright. G. There we go. Yeah. I'll show you how it works in a second. And then we'll see how it works at an x plus 3 thing. These right here are all coefficients. What I want to do is talk about the rows. This right here, you'd think it'd be the first row, but they call it row 0. Alright, and there's a reason for that. This row right here, we'll call, what do you think, row 1. Alright, and I'm not going to write the word row every single time. And then this one here is row 2, row 3, 4, 5, and 6. Okay, you see it? Look right here. See that number? See that the second number in? That's row 2. That's row 3, row 4, row 5, row 6. That's why this is row 0. You get it? Okay, because there's really like a 0 right there, if you want to think of it that way. Alright, so those are our rows. Now those rows represent our exponent. Alright, so like, tell you what, let's do this. Where's the best place to write this? I didn't leave myself much room. Let me try something. I don't know if this will work, but let's try it. Ah, it does. Yes, look at that. Thank goodness for technology. Alright, that's what I wanted to do. Just wanted to make it a little bit smaller. See, I couldn't do that on chalkboard, could I, or a whiteboard? So that's pretty cool. All right, what I want to do is this. That row 0 right there, I'm going to write it right up here. You know how I had x plus 3? Instead of x plus 3, I'm just going to write x plus y. Right? That represents any numbers, okay? And so this is going to be like x plus y to the 0 power. What's anything to the 0 power equal to? It's equal to 1, isn't it? All right, so that's not that big of a deal. But as we start going down, they start becoming a big deal. Watch this. X plus y to the first is what? Just x plus y, or x to the first plus y to the first. I want you to see something here as we go on. We're going to establish a pattern here too. So x plus y to the second is going to be, watch, if I multiplied this out, I would get x squared plus, it's not x squared plus y squared, is it? Because I got to go x plus y times x plus y. So it would be x squared plus xy, which would be what? Plus 2xy plus y squared. You see that? I want you to see this. These exponents correspond to the rows. Look at this. This is row 1. Okay, do you see row 1? Yep. Look at the coefficient. What's the coefficient in front of the x? It's a 1, isn't it? What's the coefficient in front of the y? It's a 1. Do you see how this is a 1 and this is a 1? Those numbers. Yeah, so that's a 1, that's a 2, and that's a 1. Exactly right. You see it? Okay? And then what do you think the next one's going to be? Do you remember? I'll just do it. I'm not going to work it all out. Watch, this is going to be 1x squared. I'm sorry, it's not x squared, it's x cubed. And I want you to start looking at the coefficient, or the exponents. Now, these exponents don't really show up in this little chart right here. This is just for the coefficients, all right? This is only used for the coefficients. But there is a pattern that's being established with the x's and the y's, all right? And you'll see it when we do a couple more of these. You'll see that pattern a little bit more. So this is plus. What's my next coefficient? 3. Then watch what's going to happen. This is going to be an x squared, and this is going to be a y. I'm not going to show you the pattern until we do another one. Plus another 3, and this is going to be x, and this is going to be y squared. And then, what's the coefficient for the last one? 1, and that's going to be a y cubed. Make it look like a 3. There we go. I want you to look now at see if we can see a pattern. Look at the x. Started off with cubed, which was the same exponent as we started out with right here, isn't it? Look what happened. It went x cubed, then what did it do? Went x squared, then what did it do? X to the first, and then basically went x to the 0, didn't it? Do you see that? See that? It started off with this exponent, and then it gradually went down. It went 3, 2, 1, 0. Look what the y's did. There's no y in the first one, is there? So basically it's y to the 0, if you want to think of it that way. And then it went up. So it started off with 0, then it went to what? 1, then it went to 2, then it went to 3. Do you see the pattern? All right. And what's the pattern with the coefficients? It's all taken from this triangle. So if you can remember the patterns, then it's really easy to do these problems. Okay. Let's do another one. We'll do a couple more. To the fourth. Let's see, just by looking at this, what we're going to do. What's our coefficients? It's 1, 4, 6, 4, 1. You see it? So it's going to be 1 what? X to the 4th, okay? And the y is just going to be y to the 0, right, which is a 1. Plus, what's my next coefficient? 4, and then it's going to be what? What happens to my x? It goes what? It goes down, and now my y starts on its way up. So now that's y to the 1st. See it? Plus, what's my next coefficient? 6, right? It'd be x squared, because that works its way down. Now my y works its way up. So it's y what? Squared. You with me? And then what's the next coefficient? Plus 4, just at x, and this is going to be y cubed, plus the next one, it's just a 1, and look, the x goes down to x to the 0, which is a 1, and then y goes all the way up to y to the 4th. Make sense?
So either way, your variables are going to be the same, will have the same exponent at the end.
Yes. Yes, this exponent and this exponent will be the same at the end, correct. Let's do one more.
question.